In this section, we're going to be making models for covalent bonds using this gizmo. Follow the instructions on Canvas to set up your account and use the class code to join. Once you got all that set up, you're going to hit Launch Gizmo. The first part of this is just a prior knowledge question, so this is something you think about before actually starting the activity. It says, ponder, there are 8 markers in a full set, but Flora and Frank each only have 7 markers. Flora is missing the red marker, and Frank is missing the blue marker. What could they do in this situation? You're going to just jot down your thoughts in that space. We're going to move on to the gizmo warm-up. Just like the students described above, non-metal atoms can share electrons. As you will see in the covalent bonds gizmo, atoms form bonds in this way. To begin, we're going to check that fluorine is selected, which it is, and then we're going to click play to see those electrons just moving around the nucleus. And then number 1 says the outermost electrons in each atom are called valence electrons. How many valence electrons does each fluorine atom have? They're going to write that in this box here. Number 2, click pause. Drag an electron from the left atom to the right atom. And then click play. And then in this box, you're going to write down what happens. And then 3, we're going to click pause. Drag an electron from the right atom to the left atom. And then click play. And again, in this box, you're going to write down what happens. And now we're going to move on to activity A, sharing electron. We're going to click reset. We're going to select hydrogen. And then the intro says, the electrons that orbit the nucleus of an atom are arranged into shells. The first shell contains up to 2 electrons, and the second contains up to 8 electrons. Most elements are stable when they have 8 valence electrons, a rule of thumb known as the octet rule. Elements with less than 5 electrons are stable with 2 valence electrons. So there's exceptions to this rule. So the question is, what happens when atoms share electrons? Number 1, you're going to predict. So each hydrogen atom has 1 valence electron, but it needs 2 electrons to be stable. How can both hydrogen atoms each achieve a stable configuration? You're going to write down your prediction in that box right there. Number 2, form a bond. Drag the electrons so that they move around both hydrogen atoms. And do that. And then it says click play to observe them in orbit. Click check, and it looks like our atoms are stable. We created a molecule of hydrogen. So now we're going to do this again. Number 3, we're going to form a bond, but we're going to do this with fluorine instead. So this is your turn. To practice this, you're going to move those electrons around to try to create a molecule of fluorine. Once you do that, take a screenshot of this, put it in this section, and remember you can check by clicking that check button. We're going to move on to activity B, building molecules. So we're going to click reset, turn off Lewis diagram, it's turned off. We're going to select oxygen. The question says, how do atoms share more than 1 pair of electrons? Number 1, observe. Like most other elements, oxygen atoms are most stable with a full complement of 8 valence electrons. So A says, how many valence electrons does each oxygen atom have now? So you can count, look at the model, write your answer in that box. And then B, how many more electrons does each oxygen atom need to be stable? Again, you write your answer in this box. And then we're going to move on to number 2, form a bond. Drag electrons back and forth until the molecule of oxygen is stable. Click check to confirm your molecule is stable. Take a snapshot and paste here. So you're going to paste a picture of what that's going to look like in this box here. So you got to move those electrons around until you get something that's stable. If it's not stable, it's going to show you something like this. So you're going to try that out. And then in the question underneath, it says, how many pairs of shared electrons are there in a stable molecule of oxygen? This is called a double bond. So once you get that to say that it's good, you're going to count the pairs that you have, and you're going to write that number in this box down here. And then number 3, it says practice. You're going to practice creating covalent bonds and stable molecules for the remaining substances, all the ones that you see on the screen right now. So you're going to have to change the substance by clicking on here. And you'll have to, again, play around with this, start sharing the electrons, and check each time, add more, check, until you finally get one where it says it's all good. So you're going to be drawing in the bonds on here. One thing you can do to make this easier is click on the box that says show Lewis diagram, and then you can use that to help you draw in these structures in these boxes right here. And then I'm going to show you the key So if you want to check your work, all right, so here's the key for that first part of section 7.11, so you can pause and check your work. And here's the key for that second section, so you can pause, check your work here. And then here's the key for that last section.